Hi, welcome to an Arduino tutorial from Robojax. In this video we are going to learn how we can use this DS1307 clock module for Arduino to display the calendar, including the year, month, day, hour, minute and day of weeks. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. This module is based on DS1307 32 kilohertz clock counter, and we're using the battery. It holds the time and date and updates continuously even if it is disconnected from power. It holds the full calendar, including year, month, day, hour, minute and seconds, and using those parameters can control a device, like turning it on and off based on certain date or time. For example, you can schedule a device to be turned on every day at 8 o'clock and turn off at 8:30, or a light or something to be turned on, or a device based on some other trigger. So this is a very useful module. It has broad application. Let me start by explaining the hardware. After that I'm going to show you the wiring, then I'm going to explain the code, and at the end I will demonstrate features of this and how to set the time and use it. I will have more videos related to this, make video to display time on the LCD monitor and many other applications. When you receive this module, most of the time the pins are not connected. It's called the pin header. First, insert the pin header on the breadboard, then put the module on top of the header and start soldering from one side to the end. The module that I purchased did not have this battery. The battery that you need is CR2032. This is a 3 volts lithium battery. You can also connect the connectors either on this side if you want. I use the other side. And then we have a actual chip. This is the SD1307 chip. And this is a crystal of 32 kilohertz. So this is a 32 kilohertz clock module. Make sure to use this one with this code. The job of this battery is to hold the time once the power is disconnected from Arduino or the module is set separate. Now with this battery, the clock is now running and it will not stay behind, but once you remove it, the time will be resetted. So whenever you remove the battery, you have to set the time, which I'm going to show you in the code how to do that. Let me explain the wiring. This is DS, the DS pin. The second one, the first one is left alone, not connected. DS is connected to pin 2 here, pin 2 of Arduino. And then here we have SCL. These two, SDA and SCL, are for I2C communication. And in Arduino UNO, SDA is A4 and SCL is A5. You're using Arduino UNO, and then SCL is A5 and SDA is A4. And Arduino Mega, SDA is 20, and then SCL is 21, and Leonardo, and all of those. Also, you will have SDA and SCL here, so you can connect SDA to SDA, SCL to SCL. Then we have VCC. VCC is connected using red wire to 5 volts, and ground is connected to the ground of Arduino. Let me explain the code. The first thing that you need is to download this library. I will provide you the link. The wire is part of Arduino IDE. You don't need to do it, but this one you have to download it. And once you download it, it will be a zip file. Save it in your computer, and after that go to Sketch, include library, add zip library, and then point it to the library. For example, this is for another device. Just click to that zip file that you have downloaded and click open. The library will be included. Close your Arduino IDE and reopen it. This is a header file which is part of the library. Inside this we have a class called RTC, Real Time Clock DS1307, and then we create an object out of this class. This is an object or instance of this class, and this is day of week. This is a character of 7 item, each with up to 12 characters. Day of the week as text. You can see it Sunday, Monday, Tuesday, Wednesday. All of them have been saved here. Then inside the setup, we check the serial, if serial exists or is it possible, because the other Arduino might not have it. If it does not exist, while means forever it will be true and the setup will not proceed. Then we initialize the serial monitor with 9600 baud using serial.begin. This 9600 is the value that is at the lower right corner of the screen in serial monitor. And you can open serial monitor by clicking here or by clicking at the tools and serial monitor. Then we check RTC.begin. This is initializing the real-time clock. This means if it is not true, which is usually if it works, it will be true. It will print this, and while 1 means stay forever. And then is running. There is another function. It is checking if it is running. If it is not running, it will print this error. Do not worry about that. And inside the loop, here is the important part. We initialize, we are getting the current time, RTC.now. This is getting the current time from the clock module and is storing it in a variable called now. This is an object of date and time. Now.air, comma, decimal. This is a number. It prints 2019, and the next line we print this forward slash, and then we get the month as a decimal 3, and then we put forward slash, and after that we open a parenthesis, and then day of week. This is a number, either 0, 1, 2, 3 or 4 up to 6, and this number, if we type here 5, for example, if we type here 5, it will go inside this array and get elements number 5, and the elements is here. This is 0, 1, 2, 3, 4, 5 up to 7, and whatever day of week we have, now dot day of week will return a number between 0 to 6, which is day of the week, and then we convert it to a text to print this Monday for us, and then we close it. After that we set hours. This is getting 21, which is my current time, and then we put colon, this colon here, 2 dot on top of each other, and then minute 40, and then we print second. After that ln, this new line, this goes to the next line and then print this text. The Unix timestamp, this is a timestamp that is widely used in the industry, and it has started from first month and from first day and first month of 1970, January 1st, 1970, and since then this many seconds have passed. So these are number of seconds, and then they put S for us, and then this 86,400 is number of seconds in a day. 24 hours times 60 minutes times 60 seconds is 86,400, and L refers to the data type long. Future time, for example, current time, time span, and we can say 7 days and 30 seconds from now. Future.year will get this calculation added to the current time. That will get us the year, month and date, the same as before, including minute, hour and second, and it prints it like that. Here is a demonstration. As you can see, this is now connected via USB, and this is the time that you are getting live. If I disconnect this scrolling of data that is coming will stop. This will not now scroll because the information is not coming. If I connect it and then close this and open it again, you will get the latest information from this. And this was the information or data that I have explained to you. Now I will remove the battery and show you that the time will be resetted. This is the bad battery. that one terminal is in here, the other terminal is in here. When you remove or work with this battery, pay attention. If this is one terminal and the positive is on this side, the negative is on this side, and they have been separated with insulator in here. If your screwdriver somehow connects both of these, your battery will be discharged immediately. This is now a bad battery, so I can do it, no problem. But for this battery, now it's very important that at the bottom I have to be careful. But to remove the battery, I just pull this down and the battery went out. Now the clock is running properly. Now I'm going to disconnect it and give it a few seconds. The time should be resetted. And now connecting it again. There is no battery. Let me close this and open it. As you can see, it shows that the time is year 2000, Saturday, and it says it's not running because the battery is not there. You see, RTC is not running, and also the time is January 1st, 2000, and hour, minute, and second is 000. Now let me just insert it. And even if I open it again, it will not be updated. Still, this is an old time. We have to set the time now. And here inside the setup, I'm leaving this. It says adjust. You can do adjust and put your own time, whatever time you want. The first one is, this is year, month, day, hour, minute, seconds. So this is an order from the largest unit to the smallest. Remember, month is first and day is after that. But if you want to get your system or your computer time, just put this line, which is inside day of time. There is an F, and then F will use less memory, and then this is the compiler date with 2 underscore. This is 1 underscore, another one, date, and then time. And let me uncomment this. Once you uncomment it, this is now connected. Upload the code. Now if I open this, you will see we are getting the current time from my machine here, 21:55, and it is exact time. After that, when you see that time is set, comment this again and upload it now. This time it will just upload it because the battery is here, it will hold the time. Now it shows the time, and even if I disconnect it, close this, wait, and then connect it again, and just open the serial monitor, you will see that the time has been updated 21:56. That's the time. Thank you for watching. If you learned from this, please thumb up. Don't forget that, and also leave the notification on, and also subscribe so you can get updates of my upcoming other videos. The battery that you need is CR2032. This is a 3 volts lithium battery. You can also connect the connectors either on this side if you want. I use the other side. It's up to you. And then we have a actual chip. This is the